Hi everyone, let's do some differentiation using the product rule. So if you recall, to find the derivative of two functions being multiplied together, we're going to take the derivative of the first function times the second function plus the original first function times the derivative of the second function. And this is written here in Newton's notation, and underneath is Leibniz. They both might get used through the video, so it's useful to know. But they're both just demonstrating that to get the derivative of a product, we're going to multiply the derivative of the first function times the second function plus the original first function times the derivative of the second function. So let's practice with this problem. F of x equals 3x squared minus 5x times e to the x. So let's first find f prime and g prime. F prime is going to be, using the power rule, 6x minus 5. Considering this is f and this is g. G prime is just going to be e to the x. So plugging into our equation, f prime, which is 6x minus 5, times g, which is e to the x, plus original f, which will be 3x squared minus 5x, times g prime, which is, again, e to the x. So we can simplify this a bit, and what we'll do is pull e to the x out so that we can combine like terms. So this gives us e to the x times 6x minus 5 plus 3x squared minus 5x. And combining like terms, we get e to the x times 3x squared. 6x minus 5x is x minus 5. This is our solution. Here we have f of z equals 1 minus e to the z times z plus e to the z. So we have our f here and g here. F prime is just going to be negative e to the z. G prime is going to be 1 plus e to the z. So plugging into our product rule equation, f prime of z equals f prime, which is negative e to the z, times g, z plus e to the z, plus f, 1 minus e to the z, times g prime, 1 plus e to the z. So here we're going to go ahead and distribute so we can simplify. Negative z e to the z minus e to the 2z plus 1 plus e to the z minus e to the z minus e to the 2z. So now we'll combine like terms. And let's rewrite this first. Negative z e to the z minus e to the 2z. And let's just remember to distribute this addition sign to each term, so that we have plus 1 plus e to the z minus e to the z minus e to the 2z. F prime of z equals negative z e to the z. We have minus e to the 2z minus e to the 2z, so minus 2e to the 2z. And then here we have positive e to the z minus e to the z, so they'll just cancel, plus 1. This is our solution. Let's look at f of x equals x cubed minus 2x times x to the negative 4 plus x to the negative 2. So this is definitely a product rule and something we can solve with the product rule, but also something that's helpful with some equations is to distribute, and you can simplify it even more. So that's what we're going to do here. We're going to FOIL each of these. So f of x equals x cubed times x to the negative 4 will be x to the negative 1. X cubed times x to the negative 2 will be x to the 1. Here we have negative 2x times x to the negative 4. That'll be negative 2x to the negative 3. And then for the last term, negative 2x times x to the negative 2. That's going to give us negative 2x to the negative 1. Sorry. So now you see, since we've distributed this, they're all just a bunch of simple power rules. So we have f prime of x equals negative x to the negative 2. X to the 1 is just x, and the derivative of x is just 1, so plus 1. Here will give us negative 2 times negative 3, that's going to be positive 6x to the negative 4. And negative 2 times negative 1 is going to be positive 2x to the negative 2. Now let's combine some like terms. F prime of x equals 6x to the negative 4. I have negative x to the negative 2 plus 2x to the negative 2, so plus x to the negative 2 plus 1. And this is our solution. For next example, we have f of x equals x minus the square root of x times x plus the square root of x. This form could look a little familiar because this is something we deal with often. It's actually a difference of squares. If you recall, a squared minus b squared equals a plus b times a minus b. So here we could see a is x and b is the square root of x. So if we rewrite this, a squared is x squared minus the square root of x squared is just x. So this is also f of x. And this is something that's a lot easier to differentiate because you can do it just using the power rule rather than the product rule. So using the power rule, we have f prime of x equals 2x minus 1. There we have it. So here we have y equals x squared plus e to the x times the square root of x. We have our f here and g here. So f prime is 2x plus e to the x, while g prime is going to be 1/2 x to the negative 1/2. So using our equation for the product rule, we have f prime, which is 2x plus e to the x, times g, we'll write it as f to the 1/2, plus f times g prime. So now let's distribute here. 2x times x to the 1/2 is going to be 2x to the 3/2 plus x to the 1/2 times e to the x. And on the other side of the addition, we have x squared times 1/2 x to the negative 1/2. So that gives 1/2 x to the 3/2 by adding the exponents. And then we have plus 1/2 x to the negative 1/2 times e to the x. So we have these two terms that we can combine. We have 2x to the 3/2 plus 1/2 x to the 3/2. So to represent 2 in the fraction way, we're going to add 4 halves to this 1/2, which gives us 5/2 x to the 3/2 plus x to the 1/2 e to the x plus 1/2 x to the negative 1/2 e to the x. I'm going to erase some stuff up here. And move this up a bit. So if we look and see, we'll notice that these two are very similar. We just have 1/2 root x in a denominator, and then in the second term it's in the numerator, over 1. So we can go ahead and pull out 1/2 e to the x, because they share an e to the x as well. So down here we have 5/2 x to the 3/2 plus 1/2 e to the x times, and when we pulled 1/2 out of this x to the 1/2, that means we have 2x to the 1/2. Because if we distribute this back, we'll see the 2's cancel and it's just 1. And then we have plus 1 over x to the 1/2. And that's our solution. It's y prime.